Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Kerfuffle by Nicholas Duhale, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Excuse me. The sum of the digits along an arrow is equal to the digit in the connected circle. So, for example, if we had, say, 3 and 4 here, this would have to be 7 because the digits along the arrow must sum to the digit in the connected circle. We also have white dots join cells with consecutive digits, and not all dots are given. So, for example, if we had a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Where do we start here? We know the circles is the sum of 2 unique digits in every case. So these have to be 3 through 9. Okay. What does that tell us? I'm not sure. Oh. Okay, that's one thing. Every time you have a arrow in the same box as a circle, that means those two digits must sum up to that digit, which means that that sum of those digits there must be an even sum, right? Because the two digits on the arrow add up to the digit in the circle, so therefore it's equal to 2 times the digit in the circle. So these are an even sum. This is an even sum. In a box, you'll add up to an odd sum. So, and every pair of consecutive digits has to have one odd and one even, which is an odd sum. So therefore, this is an even sum, odd sum. So to add up to an odd sum with an already odd set, this must be even. So this is 4, 6, or 8 here. Okay. This is odd and even, odd and even, odd and even. So that's 3 odds and 3 evens here, which adds up to an odd sum. And this is even. So to add up to an odd sum here, so this is even. This must be even also. Even plus an odd sum gives you an odd sum total. So we know these are all even. This is 1 odd and 1 even. Here, that gives us an odd sum for these 7 digits, which means this must be an even sum. So this must be an even sum here. Interesting. What else do we have? This is even, this is even. We have 2 sets of odd and even pairs, so that would give us 2 evens and 2 odds, which adds up to an even sum. So this is even, this is even. We have even here, so this must be odd here. What else do we have? Do we have anything else? Not particularly. We don't really have any information here. Or here. This is 4, 6, or 8. Oh, where is 9 in column 4? I think that's where we have. Well, can't be on these arrows. 9 can never be on an arrow summing up with another digit to add up to a single digit. So none of these can be 9. And these can't be 9 for the same reasoning. So 9 has to be, because these are both even, this has to be 9 here, which makes this an 8-9 pair, which eliminates 8 and 9 in the rest of the column. Well, where is 7 in this row? Can't be here. And the 7 has to be either here or here. And if 7's here, it must be 1 and 7 adding up to 8. If this is 7, it must be 1 and 7 adding up to 8. So that eliminates 1 in the rest of column 4. So this cannot be 1 and 3 adding up to 4. This must be a 6, which means this must be 2 and 4 here, which are both even. That means we are left with 1, 7, and 3, 5 as the remaining digits in column 4, which must be then adding up to 8 either way. So this is guaranteed to be 8. This is guaranteed to be 8. 8 eliminates 8 here, so that's 9, which makes that 8. So this is even. That means the rest of column 4 are all odds. Okay. Where is 9 in this box 1 then? 9 cannot be here because that's only consecutive with 8. So 9 can't be on the arrows. So 9 has to be one of these two digits. We don't know which. This is 8, which must be either 1, 7, 2, 3, 5, or 2, 6, adding up to 8. Where is 9 in this row, in row 9? It cannot be here on the arrows. It can't be next to the white crop key dots because it can only be consecutive with 8. So therefore, it must be here. So this is 9, which means we have a 9 guaranteed in one of these two cells and a 9 guaranteed in this cell here. Whereas the 9 in box 4 cannot be here, cannot be here, cannot be on the arrow to sum with another digit to add up to another digit. So this must be 9 there. Okay. Don't know about consecutiveness here or here. Where is 9 in box 2? It can only be next to a white crop key dot, so it has to be next to an 8. Well, 8 can't be here, and 8 can't be here in box 2, so 8 has to be one of these two digits. So the 9 must be consecutive with it, so 9 has to be one of those two digits. Interesting. This digit cannot be 9 or 8, so we have 3 through 7 there. That means this cannot be less than 7. Sorry, cannot be greater than 7, or 7 or greater. So this is 1 through 6. Cannot be 2 and 4 here because of the 2-4 pair in the box. So this could be 1, 3 adding up to 4, 1, 5 adding up to 6, 1, 6 adding up to 7, but 3 and 5 doesn't work because that adds up to 8. So this always is guaranteed to have a 1 here. Interesting, which means we cannot have 1 anywhere else in the rest of the column. So this can't be 1, which means this can't be 7. Um, hmm. Um, what else do we have? 9 cannot be here. So where is 9 in box 5? It has to be one of these two digits because it can't be on the arrow. That 9 eliminates 9 from being here, so this can't be 8, which means this has to be 9 here, and that's 8. Okay. So this is even, this is odd. Remaining digits in box 2. Well, we can't have a 7 because 7 would be consecutive with another digit if they were next to a white crop key dot, but 6 and 8 are already taken. So this must be 7 here, which makes this a 1-7 pair, which eliminates 1 and 7 in the rest of the column. So this is 3-5 as a pair. That eliminates 3-5 as a pair here, because this adding up to 3-5 here would eliminate all possibilities for this cell. That leaves this as 2, 3, 4, and 5 as quadruplet. Okay. This is an odd digit. Um, hmm. What consecutive digits can we have here? 1, 2 does not work. It eliminates all possibilities for this arrow. 6, 7 doesn't work. It eliminates all possibilities for this arrow. 8 and 9 obviously don't work. So we could have 2, 3, 3, 4, 4, 5, or 5, 6. That's quite wide variety. Huh. Remaining, okay, so this is 2, 6, or 7. If this is 2, this cannot be 3 because of the 3, 5 pair in the box, so this would have to be 1, which is not possible because we have, this is guaranteed to be 1 here for this arrow to work. So this cannot be 2, which means this can't be 6, so this is 1 or 2 here. 6 cannot be with 5 here. So if this were 6, this would have to be 7. Otherwise, this is 7, which eliminates 7 in the rest of the box. So this can't be 7. So if this is 7, this could be with 6 or 8. We have a guaranteed 7 here, though. Where is 2 in this box? Where is 1 in this box? 8 eliminates 8 here. So this is not... This is a 6, 7 pair, which eliminates 6, 7 in the rest of the column. So this can't be 6. It's 4, which is a sum of 1 and 3. Well, where are 1 and 2 in this box? They have to be here, which eliminates 1 and 2 in the rest of the column. So this can't be 2. It's 3, 4, and 5, which eliminates 3, 4, 5 in the rest of the box. So this can't be 3, 4, 5. It's 2, which is consecutive only with 3 out of 3, 4, and 5. That eliminates 3, 4, and 5 in the rest of the row, or column, I should say. So that leaves this as a 6, 7, 9 triplet. No 9 here. Remaining digit in column 6 is a 5. So we have 2 and 3 there. What can these sums be here? 9 cannot have 1, 8, so if we have 9 here, that forces this to be a 4, 5 pair. Which would force this to be 1 and this to be 7, 8. If it's not 9, it can't be 8. Can it be 7? 7 can have 1, 6, 2, 5, or 3, 4, but those are all eliminated by the possibilities here. So no. We can't have 6 here. Can we have 5 here? 5 with 1 and 4. We are guaranteed 5 with 1 and 4. That does potentially work. No, it doesn't. Yes, it does. Where is 8 in row 3? 8 cannot be here because of the way that this row unfolded. So this must be odd. So 8 has to be here, which makes this 7 or 9. Obviously, if this is 9, this is 7 and 8. If this is not 9, this has to be 8 and... Well, 9 could be here. So we could have 5 with 1 and 4 there. That's a possibility. And then this would be 7 or 9. And then we have the other 7 or 9 there. So 4 has to be one of these two. 4 cannot be here because that would be the sum of 1 and 3. So 4 is guaranteed to be one of those two digits there. We have a guaranteed 7 as one of those 3 digits. This must be consecutive. If this is 5 with 1 and 4, this has to be 9 with 2 and 7. Because... Or it could be 3 and 6, I guess. Ooh. Okay, so we know 4 has to be here. 5 has to be here. That means these consecutive digits can be 1, 2, 2, 3, or 5, no 5, 6, it's 6, 7. So those are the possibilities. Okay, so remaining digits in this box cannot have 4, 5, or 8. So we have, what, 1, 2, 3, 6, 7, and 9. 9 could be there. This obviously can't be 1 or 2. Can we have 3 here? 3 with 1 and 2 would leave that as 6, 7. So that's a possibility. Three with 1 and 2. 6 doesn't add up. Because if we try to have 6 here, we don't have 1, 5, or 2, 4 available. 7 doesn't work, because that would force us to be a 1, 6 pair to add up to 7, and that would eliminate all possibilities for this cell. So this is 3 or 9. Interesting. If it's 9, it could be 2, 7, or 3, 6. Can't really be 9, can it? This digit has 3 digits smaller than it in the same box, so this is at least 4. So it's 4 through 8. So if this is 3, this is 1, 2. And this becomes 6, 7. This is 9, 4, 5. If this is 9, This is 514. And that's not possible. Because to add up to 9, we have 2, 7, and 3, 6. But then that would force this to be 2, 7, or 3, 6, which is not consecutive. So this cannot be 9 here. It must be 3. That forces this to be 9 there, which adds up to 4 and 5. 3 in the corner. That's what we celebrate because we're getting close to solving it. This is 1, 2 as a pair. And 1, 2, 3 here. It's 6, 7 as a pair, which eliminates 7 there. So that's 1, which makes that 7. 9 eliminates 9 here. So this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the row. This can't be 7 or 9. It's 1. Remaining digits left. 9 cannot be consecutive because it's only consecutive with 8. So this must be 9 here, which leaves this as 4 and 5 consecutive with 6. Sorry, 5 consecutive with 4 or 6. And this can't be 4, 1, 5 because that would eliminate all possibilities there. So it's 5, 6 as a pair, which eliminates 5 there. So that's 4, which makes that 5. 1 eliminates 1 in the rest of the column, so that's 2 and 6 adding up to 8. 6 eliminates 6 there, so it's 7. 2 and 6 eliminate 2 and 6 in the rest of row 9. So this is a 3, 4, 5 triplet, which eliminates 3, 4, 5 in the rest of the row. So this has to be 1 and 7. That adds up to 8 here. So this cannot be 1, 7 because this 1, 7 pair eliminates all possibilities for that being 1, 7. Cannot be 3, 5 because of 3 in the column. So this is 2, 6 as a pair adding up to 8, which eliminates 2, 6 in the rest of the column. So no 6 here. It's 7, which makes this 6. Okay, we are guaranteed a 4 here. Where is 9 in row 8? Cannot be here because of 9's in the... Oh, I should have been able to figure that out. So this has to be 9 there. Because 9 cannot be on an arrow, adding up with another digit to add up to a single digit because it's the largest digit. This can't be 1, 8 because of 8 in the row. No 2, 7 because of 7 in the row. No 4, 5 because of 4 in the row. So this must be 3, 6 as a pair, adding up to 9, which eliminates 3, 6 in the rest of the row. This can't be 3, it's 5, which makes that 3. No 3 here, it's 4, 5 as a pair. Which leaves the remaining digits in row 8 as 1, 2, and 4, but 1 can't be here because of the 1, 7 pair in the row. So this must be 2, 4 as a pair, which eliminates 2 and 4 in the rest of the row. So no 2 there, which makes that 1, which makes that 2. 2, 4 as a pair eliminates 2 there, so it's 6 and 2 there. This adds up to 9. We can't have 2, 7 because of 2 in the box. We can't have 4, 5 because that would eliminate all possibilities there. So this must be 1, 8 or 3, 6. 8 can't be here, so this can't be 1. 7 eliminates 7 here, so this is 1, which makes this 7. Remaining digits in column 1 are 4 and 5. 5 eliminates 5 here, so that's 4, which makes that 5. 4 eliminates 4 here, so it's 2 and 4. Remaining digits of box 7, we have 3 and 5. Remaining digits of row 7, then, are 1, 7, and 8. This can't be 1 because of 1 in the column. Remaining digits of row 2 are 2, 3, and 4. This can't be 2 because of 2 in the column. Where is 2 in row 5? Cannot be here because of 2 ones in the boxes. Can't be here because of 2 in the column. Can't be here because 2 cannot be the sum of 2 unique digits that are not 0. So 2 has to be here, which eliminates 2 there. So that makes that a 2 there. And we should have We don't. Where is 8 in column 2? Can't be here because of 8 in the boxes. Has to be on the arrow. So this must be 8 and 1, which eliminates 1 in the rest of the column. So that's 2 and 1. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 5 and 4. 5 eliminates 5 here, so it's 3 and 5. 8 is only consecutive with 7 or 9, and this can't be 9 because of 9 in the box. So that's 7. That makes this a 3-6 pair here. Okay. 7 eliminates 7 here. Remaining digits of row 8 or 5. We have 1, 3, 6, and 9. No 1, 9 here because of 1, 9 in the column. No 1 here, obviously, because 1 can't be the sum of 2 unique digits in normal Sudoku. 3 can't be here because this cannot be 1 and 2. 6 can't be here because this can't be 1, 5 adding up to 6 or 2, 4 adding up to 6. So therefore, this must be a 9, which makes this a 6. That makes a 7 and 9. 6 eliminates 6 here, so it's 3. 3 eliminates 3 here, so it's 1 and 3. 3 eliminates 3 here, so it's 6 and 3 there. This adds up to 9, and we don't have 2, 7, 3, 6, or 4, 5 available, so it's 1 and 8. This can't be 1 because of 1 in the column, so this is 8, which makes that 1. 8 eliminates 8 here, so it's 7. 3 eliminates 3 here, so it's 6. And it also eliminates 3 here, so it's 4, which makes that 3. 6 eliminates 6 there, so it's 3. This can't be 1 or 7 because of 7 in the row, 1 in the column, so that's 8, which makes this a 1. 8 eliminates 8 here, so it's 7, which makes this 8. The remaining digit in row 4 is a 6. That makes this not 6, so it's 5 and 6. 5 eliminates 5 here, so it's 4 and 5. Remaining digit here is 5. Remaining digit here is 4. Remaining digit here is 7. Pretty interesting, actually. It was interesting how these arrows interacted with each other. Especially with the Kropki dots, too. Yeah, I mean, the logic is not very commonly... Well, I mean, it's used decently as a rule set, but I don't know if it's actually that common. Where you basically try to sum up all these sums, right? And then identify it with an odd even pair for the white Kropki dots, which gives you odd and even values in certain places. I don't know. That was just sort of where immediately I was like looking at. But that's not necessarily intuitive for most people, I would say. It was the thing that really struck me, though. I don't know why. It just basically was something I was like, oh, well, yeah. I don't know. Maybe that's not so easy for a break-in, but I mean, for me, that's where my mind went to instantly. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.